Chapter 4, Section 4.1, Chemical Equations, Chemical Reactions. You're going to be able to identify the parts of a balanced chemical reaction, including the phases. You're going to be able to write complete and balanced chemical equations based on either some word that's obscured behind my video box, symbols, or word descriptions. So I presume that word is chemical symbols or elemental symbols. Okay, now let me just give you a little bit of a heads up. Chapter 4 is a hefty chapter. So I'm going to work through this pretty deliberately. So I'm going to break this up into a lot of pieces. And I don't know if I apologize for that. Really, I think I should be saying, you're welcome. Which I've watched the movie Moana about 245 times. If you haven't seen it, it's really wonderful. But I have small children, so I watched it. Yeah, I've watched it a lot. Anyway. Okay, information in a chemical equation. So first of all, what you need to wrap your mind around is a chemical equation is presented like what we've got right here. Oop, that's not supposed to be like that. We've got this right here. Okay. Now, what we have are reactants that rearrange their bonding to form products. Okay. On the left-hand side, we've got our reactants. On the right-hand side, we've got our products, and we've got this nice little arrow pointing us from our reactants to our products. Chemical formulas tell you what happens during that reaction. Coefficients are the very important part that tell you what proportions the reaction occurs. Okay, so now what I'd like you to see is if we've got something like this, I'm going to go ahead and say this red circle is a hydrogen, and then I'm going to go with a blue circle to indicate an oxygen. Okay, so that told us H2 plus O2 yields H2O. Okay, so let me write this again. So I think that it would be fair, based on what we've got right here, to draw oxygen something like this. That's a double bond between those two. And then hydrogen, something like this. H. Or actually, here, let me go give that visual representation. There we go. And the bonding isn't particularly important. We'll get to that later on this semester. But here we go. Okay, so we've got two hydrogens and two oxygens. And somehow we are going to produce, let's see, this is one oxygen and two hydrogens. Okay. Oh, wait, I gotta color this one. There we go. Okay, so now with that representation, what do we have that is the exact same on the reactant side and the product side? Well, we've got the same number of hydrogens, which is great. But what about our oxygens? Well, this should, I mean, you would expect maybe that there would be an extra oxygen, a single oxygen floating around. But that's not the case. And that makes sense because, and you should know that's not the case because what do we know about oxygen? Well, oxygen is one of those diatomic elements, H-bron on cliff, that oxygen there. Okay, so it prefers to be as an O2. So if we don't have like a remainder oxygen, instead what we've got is we've got an additional H2O molecule. Okay, now if that were the case, well, that would balance our two oxygens. But what happens with our hydrogens? Well, those become unbalanced. So how would we offset that? Well, we'd offset it like this, by adding another H2. So effectively what we got, and I'm going to erase this right here, effectively what we have here is the visual of our two different molecules. We have one O2 molecule reacting with two H2 molecules to form two H2O molecules. Okay, so that's what's transpiring here. That's what's taking place. We've got these two H2s, one O2 to produce two H2Os. Okay, now the way that we would write that out is by manipulating our coefficients. So I'm going to switch to a black pen. I'm going to write 2 is going to go in front of that H2, and 2 would go to that H2O. All right, I hope this is helpful. We're going to proceed onward with this chapter in the next video.